Imagine standing in a buzzing factory floor, giant machinery flowing rhythmically, powered not by gears, but by invisible forces squeezing liquid and air. James L. Johnson kicks off Introduction to Fluid Power, right here, in hydraulic presses lifting tons with smooth precision and pneumatic tools delivering bursts of energy. But how do these systems actually work? And why should you care about fluids instead of engines? Let's crack open this world where pressure rules and simple physics turns into industrial magic. First up, hydraulics, the powerhouse behind everything from bulldozers to aircraft brakes. But what makes liquid so unstoppable? Let's zoom into a real machine and see the secret. At the Alcoa plant in Pittsburgh, colossal hydraulic presses compress aluminum with up to 10,000 psi. Operators like Jim Klein witness how these presses shape airplane parts with precision that manual force simply couldn't match. The liquid inside these machines transfers power reliably, no matter how massive the load. Think of Pascal's principle like a party trick with a water balloon. Push on one side, and the pressure races evenly through every drop inside. Johnson explains it as a hidden force multiplier where a small input squeezes a large output, transforming gentle pushes into crushing strength. This liquid-driven muscle delivers smooth, exact movements where clunky gearboxes would falter. The payoff? Machines that work quieter, safer, and handle vastly heavier loads with surgical precision, a game-changer for factory floors and heavy equipment alike. Now swap liquids for air. Pneumatics might sound light, but they pack surprising punch in factories and tools. How does just pressurized air turn into versatile power? Let's unravel the buzz. In Toyota's factories in Japan, workers rely on pneumatic tools to tighten bolts with consistent force, reducing fatigue and error. The air compressors feed tools like a steady breath of energy, keeping the assembly line humming without messy leaks or heavy hydraulics. Picture pumping a bike tire. Compressed air stores energy you release suddenly for a quick burst. Johnson likens pneumatics to a spring-loaded catapult, storing energy in invisible air and then unleashing it in fast, controlled blasts. What this means for industry is huge. Pneumatic systems are cleaner, cheaper, and safe for quick, repetitive actions. Whether you're inflating tires or powering robotic arms, air's light touch can outpace oils and liquids in speed and simplicity. Understanding theory is just the launch pad. Johnson guides you through actually designing fluid power systems, from picking parts to crunching numbers. This is where knowledge turns to skill. Johnson presents exercises like sizing a hydraulic cylinder to lift 5,000 pounds at 3,000 psi. These aren't just textbook numbers. They're real-world scenarios reflecting what engineers face daily, sharpening your problem-solving against authentic challenges. Each chapter packs detailed color illustrations and schematics. These visuals aren't decoration. They decode complex assemblies into readable blueprints, helping you visualize how each component fits and functions before you even touch a wrench. The book assumes only algebra and guides you through formulas that calculate flow rates, pressure drops, and cylinder speeds. Think of these equations as your backstage pass, revealing how performance tweaks at tiny levels unlock massive efficiency gains in the field. Remember that factory floor we stood on at the start? Now you know the invisible forces, liquids and air, that make those machines dance. Fluid power isn't just physics, it's practical muscle with a pulse. Next time you see a hydraulic press or pneumatic drill, try to spot the quiet pressure backstage. Your turn. Sketch a simple hydraulic system you use or imagine. Feel how power flows beneath the surface. Subscribe for more book summaries like this one.